Hello, I'm back again. Today we're going to take an even more in-depth look at some transformations. Today, in fact, we're going to do a more in-depth look at reflections and translations. And in order to follow along with me here, one of the first things I would do if I were you is pause the video and go ahead and download the worksheet that goes with this. That's going to be your homework. The one titled More Reflections and Transformations. Okay, so if you have that downloaded, I'm going to show you a few sample problems off of there, and then I'll have you complete the rest for homework, just like you should have done with the previous lesson that was titled Transformations in that worksheet. All right, so on our worksheet, problem number 1 is a problem I'd like to do with you. It asks you to do a reflection across the equation y equals x. Okay, so what's going to make these a bit more difficult than the previous problems we did is that instead of just having you reflect over the x-axis, which would have been a flip up or down, or across the y-axis, which just would have been a flip side to side, now they're making the line of reflection a little more difficult, although it's still just a matter of flipping over the line. Okay, so the first thing I'm going to do is go ahead and create our line of reflection. Notice they gave us for the equation y equals x. So if we graph that line, remember that that would have a slope of 1 over 1 and a y-intercept of 0. So it's going to cross right here through the origin, have a slope of 1 over 1, so that's telling me to go up 1 and forward 1. So up 1, forward 1, up 1, forward 1. Okay, make as many of those as you need to be able to make a nice straight line along here. So you can see our line's going to be a nice perfect 45-degree line running uphill. Okay, so I'm going to go ahead and make that line here. And so on. Okay, so that's the line we're reflecting over. Previously, when we were reflecting over the x-axis or y-axis, remember all I did was simply count how far away we were from there. And as we flipped it over, we preserved that distance. Remember from previous lessons that distance is always measured at a right angle. So when we go to measure how far we are away from this line of reflection that I've drawn here in pink, we have to measure back at a right angle. We have to go back at 90 degrees. So if this is a 1 over 1 slope, okay, that means that perpendicular to that would be a, remember we flip it and reverse the sign, so it'd be a negative 1 over 1, because 1 over 1 when you flip it is still 1 over 1. Opposite of positive 1 would be negative 1 here, though. Okay, so basically, think of it this way. If this runs perfectly diagonal uphill, when we count back to the line, we're going to count back perfectly diagonal downhill. That's the only difference. So like, see this point Q right here? If I count back to the line perpendicular, so I go diagonally back, so I'd go up 1, back 1, up 1, back 1. Do you see that's 1, 2 full diagonal units? So I'm just going to go 1, 2 full diagonal units on the other side. So that would land me right here at this point right there. So again, I started at Q. I went 1, 2 diagonal, 1, 2 diagonal. I just keep going in the opposite diagonal fashion. Okay, so there's the new Q prime. Okay, the S, do you see, was right on the line? So when you flip it over, it'll stay right on the line. So that's not only S, but that's also going to be our point S prime. And the point R, if you look at it, it's really close to the line. Okay, it's only half of a block diagonally. So I'm only going to go another half of a block diagonally on the other side, which would land me right there at those coordinates of -2, -3. Okay, so again, see how that's just going diagonal instead of uphill? We're going diagonal downhill. So you're just going half a block. Okay, you rejoin those like such. And there you have it. You know if you've done it correctly, if as you look along your line of reflection, if it looks very symmetric on both sides of that line. It kind of looks like wings on an airplane, how these 2 points go out. So that's problem number 1. Okay, keep in mind that if our problem originally had a line of reflection, instead of y equals x, if it had been y equals -x, then the original line, instead of going uphill, the original line would have been diagonal running downhill. But other than that, the procedure would still be the same. You know, even if the line were to run diagonally downhill like this, okay, you still would count whatever points you had on this side diagonally to the line and back over on this side. So like if I had a point here, that'd be 1.5. So I go a half and a 1 again. So there would be the corresponding point on the other side of that line. Okay, and that'd be only if it was y equals -x, that the line would run downhill, because a negative slope runs downhill. All right, so that's one of our reflections across a particular line like y equals x or -x. Okay, if you look though at problem number 8 on your sheet, that's the next one I want to do. On problem number 8, they want to do a reflection across the line y equals 1. Okay, so this time our line of reflection is not going to be running diagonally. Okay, if you look, that's one of our special case lines when we were studying linear equations. That was either perfectly vertical or horizontal. In this case, y equals is a line that's going to have a constant y value. If you remember right, I kind of showed in class like this, where if you made an xy table and you fill in y with nothing but 1s, and you fill in the x's with anything you would like 0 or 2 or -3, then if you plot those points, it gives away what kind of line we have. 0, 1, as you can see, it would be located there. 2, 1 is there. -3, 1 is right here. So you see it's starting to come together. It's a horizontal line running right through the y-axis at 1. You can see it there in pink. All right, so this one is a lot like when we were reflecting across the x-axis itself. You know, when we reflected across the x-axis, it was a movement up and down. And that's what we're going to do again here, only we're reflecting over that pink line instead of the x-axis. So if you look, D up here is 1 unit above, so it'll end up being 1 unit below right here. So there's my D prime. C is directly on the line, so it stays on the line. So not only is that C, but that is also C prime. B is 1, 2, 3 units below, so I go 1, 2, 3 units above. So there's B prime. I'm going to move that C prime label on this side. There. And finally, E is 1, 2, 3, 4 units below. So 1, 2, 3, 4 units above that line lands me clear up here at 5 on the y-axis, or on the y value, I should say. So that's my E prime. Okay, I reconnect up each of those. And there's the new figure. Again, notice that it's very symmetric with respect to the line of reflection right here in pink. So it matches above and below. So again, just think of that as if we took the x-axis and elevated it up a little bit. So y equals 1. Of course, you might have similar problems where instead of y equals 1, you might have the line x equals 1. Okay, if that's the case, then instead of a horizontal line going through y at 1, you'd have a vertical line going through the x value at 1. So it'd be like that right there. And you'd be flipping side to side over that line instead of up and down. So just adjust accordingly to whatever equation they give you. But the difference, of course, between these problems and the ones we did earlier, instead of just the x-axis or y-axis, we're picking out new lines to flip over, a new line of reflection. Okay, so that's how you do those reflection problems on that worksheet. The last thing I want to show you yet is how to do some transformations on that worksheet. So if you look on that worksheet on problem number 10, that's the problem I'm going to show you next here. And on problem number 10, they give you some unusual instructions that you might not have ever seen. And the only tricky part about this is the notation they use. Okay, they tell you that this is going to be a translation, and then they write it like this. So if you look at this notation, don't let it scare you. It's really actually pretty simple. What they're saying is that these are your original values for the beginning image, the beginning shape. Our x, w, z, y here. And it says take your x values and do this to them. It says add 1, x plus 1. So if you think about it, x values, remember, run side to side. So if you're adding 1 to your x values, it means you're moving 1 to the right. If it had said a -1, I would have moved to the left. So it's just telling you on your x values whether how far you're going to move either left or right. So a +1 again is then adding 1 to your x values, so you're moving to the right. So just interpret this as 1 to the right. And then this one over here, the y -2, y values, remember, run up and down. So if it's saying take all your y values, original y values, and subtract 2, then that means we're dropping down 2. So we're going to be going down 2 with those. Had it said a +2, of course, that means you would go up 2. So we're just going 1 to the right and down 2. So all we have to do now is perform that on each point. So 1 to the right, 1 to the right, down 2, 1, 2. So there's the new x prime. 1 to the right, down 2. So 1 to the right, down 2. There's the new y, y prime. 1 to the right, down 2. There's the new z, z prime. For the w, 1 to the right, 2 down. There's the new w, or w prime. So here's the new figure. As you can see, didn't change in its general shape. It just went 1 to the right, down 2. Everything went 1 to the right, down 2. Okay? And by the way, there's a problem on there. I think it's problem number 12. But on that one, the y just does this. They have a y, and then they just have a y again. Well, if it didn't change any, then that's telling you you don't need to go up or down anything. So nothing happens to your y value. Don't go up or down. You would just do whatever it says you had to do to your x value. Okay? So don't let those scare you. Don't overthink them. Just do like it says. That's all for this lesson. Don't forget to try the worksheet and finish it for homework.